I promised to give you an example of a case where the iterated elimination of weakly dominated strategy produces rather odd results. For this, I will tell you about one of the weirdest games yet. It's a variant of the Battle of the Sexes that involves burning money. In the Battle of the Sexes game, Alice and Bob each decide to go to Costa Coffee or Starbucks. Alice prefers Costa and Bob prefers Starbucks, but above all, they want to end up in the same location. We now modify this game by giving Alice an additional choice. Before Alice and Bob leave the house to get coffee, Alice can choose to stand in front of Bob, take out a $1 bill, and burn it in front of him. With this, Alice now has 4 strategies rather than 2. She can burn the dollar and go to Costa. Let's call the strategy BC for burn and Costa. She can burn the dollar and go to Starbucks. Let's call it BS. Or she can not burn the dollar and go to Costa. Let's call this NC. Or she can not burn the dollar and go to Starbucks. Let's call this NS. But not only Alice now has 4 strategies instead of 2, Bob has 4 strategies as well. This is because Bob can decide that he would like to make his choice of coffee place dependent on whether he sees Alice burning the money or not. So his options are to go to Costa either way, whether Alice burns the money or not. Let's call this CC for Costa and Costa. To go to Starbucks either way, whether Alice burns the money or not. Let's call this SS. To go to Costa if Alice burns the money, and to Starbucks otherwise. Let's call this CS. Or to go to Starbucks if Alice burns the money, and to Costa otherwise. Let's call this SC. Bob's payoff in this new game is the same as before. He gets a payoff of 0 if he doesn't meet Alice at all. He gets a payoff of 3 if they meet in his favorite coffee place, Starbucks. And he gets a payoff of 1 if they meet at Costa. If Alice does not burn the money, her payoff is also the same as before. If they don't meet, she gets 0. If they meet in her favorite place, Costa, she gets 3. And if they meet at Starbucks, she gets 1. However, if she does burn the money, she loses the money, right? She loses this $1. So her payoff is reduced by 1 unit. A payoff of 3 when they meet at Costa turns into a payoff of 2. A payoff of 1 becomes 0, and a payoff of 0 becomes -1. This is our strange new game. Now, let's eliminate weakly dominated strategies from this game. You can pause the video and see if you can find weakly dominated strategies. I will go through the solution in just a second. So the first strategy that we notice is weakly dominated is strategy BS. It's dominated by strategy NC. So we cross out strategy BS, and after this elimination, strategy SS is now weakly dominated by strategy CS. And in addition to this, also strategy SC is weakly dominated by strategy CC. So let's actually cross out both. We cross out SS because it's weakly dominated by CS, and we cross out SC because it's weakly dominated by strategy CC. But now strategy BC dominates strategy NS. So we cross out NS. Then strategy CS is weakly dominated by strategy CC. So we cross out CS. And finally, strategy NC dominates strategy BC, so we cross out strategy BC as well. We are left with a single strategy profile. We conclude, according to this logic, that Alice does not burn the money, and that she goes to Costa, and Bob goes to Costa as well, and they are happy because they can meet there. But this is an odd conclusion to draw. So what we are saying here is that simply by giving Alice the additional option of burning money, right? She has this threat that she can burn the $1 bill. She can convince Bob somehow to agree to meet at her favorite coffee place, Costa, rather than his. And she doesn't even have to carry out the threat, right? She doesn't end up burning the money. And in some sense, her threat is not even very credible to begin with, because all she can achieve by burning the money is to lower her own payoff. Why would she ever do this? So why would the introduction of such a non-credible threat to the game make a difference to the outcome of the game? This example shows that the iterated elimination of weakly dominated strategies can lead to rather implausible solutions. To further investigate what is happening here, it is useful to find all the pure Nash equilibria in this game. So again, we mark all the best responses, and then we can easily identify the pure Nash equilibria of the game. We can see that there are 4 pure Nash equilibria in this game. But after this iterated elimination of weakly dominated strategies, only a single one of those 4 pure Nash equilibria is retained. So by using this technique of iterated elimination of weakly dominated strategies, we actually have discarded some of the pure Nash equilibria from the game, some of these stable states. Arguably, some of the lost pure Nash equilibria would have been just as plausible outcomes of the game as the pure Nash equilibrium that was kept. If we only eliminate dominated strategies, rather than weakly dominated strategies, if we only eliminate dominated strategies, we may not be able to reduce the size of the game as much. But on the positive side, it can never happen that we lose a pure Nash equilibrium. We will never erase a pure Nash equilibrium that existed in the game before by eliminating dominated strategies. But this can happen with weakly dominated strategies. So this is another reason why we should be somewhat careful of eliminating weakly dominated strategies.